This is the screencast for section 1.5, example 3, inverse relations and inverse functions. So the ordered pair a comma b, so maybe 1 comma 3 or negative 2 comma 5, whatever, is in a relation if and only if the ordered pair b comma a is in the inverse. So if you notice, the x and y coordinates switch. As a matter of fact, everything associated with the original function and its inverse switch. So domain becomes range, range becomes domain. Horizontal asymptotes become vertical, vertical asymptotes become horizontal. The point 1 comma 3 becomes the point 3 comma 1. Everything switches. Example 3 talks about the inverse, how to test whether a function has an inverse that is also a function, called the horizontal line test. You've heard of the vertical line test. This is the horizontal line test. See, the vertical line test are vertical lines that test whether a graph is a function. The horizontal line test, remember I said everything vertical becomes horizontal when you take an inverse? So the horizontal line test tests whether the inverse will be a function, the graph of the inverse. So in part A, identify the relations that are functions. So let's see. Number 1, so this we're going to use the vertical line test. Number 1 passes the vertical line test. Number 2 does not. Number 3 does not. And number 4 does pass the vertical line test. So numbers 1 and 4 are relations that are also functions. B asks which of these relations have inverses that are functions. So now we're going to test with the horizontal line test. So I'm going to draw horizontal lines, and if these horizontal lines pass through the function more than once, it's a failure. So function 1 here, actually I can draw a line that passes through and never touches the function. That's okay, as long as it doesn't cross through more than once. So number 1 passes the horizontal line test. Its inverse will be a function. Number 2 was not a function. Let's see if its inverse will be. All these horizontal lines that I'm drawing, yep, they will only pass through the graph once. So number 2, its inverse will be a function. Number 3 will not, though. I can draw a horizontal line that's going to pass through that twice. So number 3 is a no. Number 4, also a no. So the two relations whose inverses will be functions are numbers 1 and 2. The now try problem is number 9. The graph of the relation is shown. A is the relation of function. Well, let's see. Nope, it does not pass the vertical line test. Does the relation have an inverse that is a function? So I'm going to test with the horizontal line test. Actually, yeah, it passes the horizontal line test, so its inverse will be a function.